In this video, we present TableBot and the findings from our explorative work with Tabletop Telepresence Robotics in hybrid meeting settings. Hybrid communication has become the new normal for collaborating across large geographic distances. When people use digital tools to participate remotely in a physical meeting, it is called hybrid meeting. Such settings potentially lead to a lack of agency and context awareness for remote participants, leading them to often feel less engaged. Telepresence Robot is the solution for this, providing a body for remote collaborators to increase presence and agency. They are often designed for roaming large spaces, meaning their proportions and abilities make them inflexible and ill-suited for table-based collaborative settings. We have designed TableBot, a tabletop telepresence robot designed for collaborative hybrid meetings. TableBot allows the remote participant to roam the entire tabletop workspace, enabling free movement and orientation through differential steering. Tilting of the screen and camera allows access to both task and people space, clearly indicating area of focus to the co-located. The long neck and compact design of TableBot encourages grabbability, thus making inclusion and orientation of the remote a collaboration between both parties. This has been explored in a previous study, which also found that orientation was insufficient to support the distinction between the remote understanding the context and being understood. To address this, TableBot is equipped with a 146-degree camera, giving access to a periphery of information. Additionally, an LED strip is included to allow the remote to indicate direction of gaze and didactic capabilities. Through 3 rounds of study with mixed method approach, we explored readability of the LEDs, minimal acceptable view for the remote, and the ability to tilt the camera in a social setting. The first 2 studies were conducted in a controlled environment, focusing on the LEDs and the remote participants' view through TableBot. In the study focusing on the remote's view, interactions to convey locus of attention to co-located participants were also explored. In the third study, we explored TableBot in a realistic social setting by designing a custom board game to challenge every aspect of TableBot's ability. From these experiments, we found that the peripheral vision gave users the best understanding of the meeting space and allowed them to effortlessly transition between the task and people space. This resulted in the co-located experiencing a high degree of presence from the remote and allowing the remote to participate more than in the other conditions. Additionally, the pilots felt engaged and comfortable compared to the restricted view settings. One initial study showed that the LEDs can be an effective tool to indicate gaze and locus of attention. However, in the social setting, the LEDs were often overlooked by the co-located participants, making them redundant for collaboration. This was because the co-located primarily relied on the orientation of the display to understand the remote participants' locus of attention, making the remote participants discouraged from using the LEDs as a didactic tool. This may have been due to a design flaw of having the LEDs placed too low and being too subtle to be noticeable in a social setting. Ultimately, the co-located participants experienced the robot as feeling alive and as an effective extension of the remote pilot. This was due to a strong sense of presence from the remote, who in turn felt engaged and included in the space. This comfort led to the pilot sometimes playing with the system, pranking the co-located, or simply exploring the possibilities of their robot body. The collective findings from our studies indicate that tabletop telepresence can be an engaging and informative tool for hybrid meetings, making the co-located space easy to understand, while supporting remote participants in being understood. This video is part of our master's thesis at Aarhus University, focusing on improving remote collaborators' capabilities in hybrid meetings.